Hello, this is Mr. Miller. Welcome to video 9A, Introduction to Functions. Got a lot of good math to talk about in this video. So for our first example, look, I want to talk about a number machine. So this number machine takes an input, does a couple things to it, and produces an output. All right, so the name of the function or the machine is Kaboom. All right, so we take a number, we put it into Kaboom, we multiply it by 4, and then subtract 6, and that's how we get the output. So let's do that for a couple of examples. So this first one, this says 5. We want to put 5 into the function Kaboom. Function is another name for a number machine, and create the output. Okay, so we're going to do 5, multiply it by 4, we get 20, and subtract 6, we get 14. So I'm going to write 14 here. Okay, let's put negative 2 into this number machine. When we put negative 2 in, we multiply it by 4, we get negative 8, and we subtract 6, we get negative 14. All right, so this is kind of an arrow notation. This is the input here. We put it into the number machine, and this is where the output goes. This is another way of writing it. This is the input here. We're going to put 0 into the function or number machine Kaboom. So 0 times 4 is 0. Subtract 6, that would give us negative 6. So when the input's 0, and when we put it into the number machine Kaboom, out comes negative 6. That's what this means. Here, the input is 9. We're going to put 9 into the number machine. 9 times 4 is 36. When we subtract 6, we get 30. Okay, these are kind of notations not only for number machines, but for functions, which is the main thing we're talking about. All right, well, here's another machine. The inputs don't have to be numbers. In this case, the input is the word, and the output is how many letters are in the word length. So if we put happy into this machine, we calculate how many letters are in the word. There's 1, 2, 3, 4, 5, and that's the output. The inputs are words, the outputs are numbers. Let's put delightful into the machine. So when we put delightful into this machine called word length, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 letters. All right, when we put freshman into word length, that's what this means. This is the input. We're putting it into this machine. We get, well, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 letters in the word freshman. How about hippopotamus? All right, when that's the input and we put it into this machine, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 letters in the hippopotamus. All right. Number machines, or these machines, are really examples of functions. A function is something that takes an input, does something to it, and gives us an output. So this one, the input is a number again, and what we're going to do is add up the digits in the number, and that's the output. So when the input is 4,129, we're going to add up the digits. 4 plus 1 is 5, plus 2 is 7, plus 9 is 16. When the input is 283, and we put that into some digits, we get 13. Well, this is another notation. When I put this into that machine or function and add up the digits, we get, it looks like 12. And when I put 6 in, there's not much to add up. That's the only digit. The output is 6. Well, as I said, number machines are an example of functions. A function is a rule that assigns each element from the set of inputs to exactly one element from the set of outputs. I'm going to be hearing this a lot, and as we go on, I want you to really understand this definition thoroughly. Okay. Well, often functions are provided by algebraic rules. When I'm looking at this right here, f of 9, it wants us to calculate the output of the function when the input is 9. So 9, the number inside the parentheses, is the input And the number we get out, f of 9, that's a symbol for it. That's the output. And we want to figure out what that is. So this whole thing is a symbol for the output when the input is 9. Well, how do we know how to calculate the output? Well, that's what this rule is for. X in general represents the input, all right, and then the output is f of x. What this says is whatever the input is, this is what we do to it. We're going to multiply it by 3, subtract 5, and divide by 2. So when the input is 9, we're going to put 9 in for x. We're going to do 3 times 9 minus 5, all divided by 2. Well, that's 27 minus 5 is 22. Divided by 2 is 11. All right, what if our input is 13? Well, we're going to put 13 in for x. My function says whatever the input is, multiply it by 13, subtract 5, and divide by 2. That'd be 39 minus 5 is 34, divided by 2 is 17. Well, here's the next example. Here's another function here. So this tells me that whatever the input is, this is what we do to it to calculate the output. All right, so it says that whatever the input is, we're going to square it. Then we're going to add 2 times the input, and then we're going to add 3. So if the input is 6, we're going to put 6 in for x. So h of 6 would be, well, we're going to put 6 in here. 6 squared plus 2 times 6 plus 3. That's 36 plus 12 plus 3. I think you get 51. Okay, so 6 is the input. H of 6 is the output, 51. All right, well, here we're going to substitute negative 2. We have to remember, when we put negative 2 for x and we square it, we need parentheses. So h of negative 2 is what I get when I put negative 2 in for x. That's negative 2 squared plus 2 times negative 2 plus 3. That's 4 minus 4 plus 3, which is 3. Okay, so evaluating a function is a very important thing. Functions can be defined in a lot of ways, as we'll see, but this is a very common way to give a rule for defining the output. All right, here's one other one. Suppose this is our function. Find f of 6. So remember, 6 is the input, and f of 6 is the symbol for the output, the number we get out. And this is how we find it. So f of 6 is what we get when we put 6 in for x. So I'm putting 6 in for every x. And we get 36 minus 12 plus 8 divided by 4. Let's see what that is. That would be 24, and 8 is 32. Divided by 4, I do believe you get 8. All right, well, as I said, functions are very broad things and they're very important in mathematics. There are a lot of ways of showing how to go from an input to an output. Here, our function is described by a table. X is the input, and the y is the matching output. So when the input's negative 2, the output is 8. So it says find f of negative 2. Negative 2 is the input, and 8 is the output. All right. When the input is 0, the output is 0 also. Sometimes functions are listed as ordered pairs. The x-coordinate is the input, the y-coordinate is the output. So if we want to find f of 9, we got to find the ordered pair that has x equals 9. It's this one. And when the input's 9, the output is 3. And when the input is 4, the output is 2. Okay, so tables and lists of ordered pairs are kind of nice. The input-outputs are easy to find. Another way is by a graph. All right. And on the graph, the x-axis is for the inputs, and the y-axis is the outputs. To locate 2 on the x-axis, we go up to the graph, and then we go over to the y-axis and read off the output. So when a function is specified by a graph, that's pretty easy to do. Locate the input on the x-axis, go up or down to the graph, read off the y-coordinate. That's the output for that input. All right, when the input is 1, here I am. I'm going to go start at 1, go up to the graph, read out the output, 3. When the input is -2, I'll go down to the graph, over to the y-axis. That's the output. The output is -2. All right. This one is similar. When the input's -6, I'm going to go up to the graph and read it off. The output is 4. When the input is -2, we put it in this function im. That's the name for this function. Start at -2, go down to the graph, and read off the y-coordinate. That's -4. And when the input is 7, we'll go down to the graph, read off the output. It's -7. All right. Sometimes functions are just dots. All right. This is a discrete graph, individual points. Do it the same way. To find the value of the function when the input is 1, go to 1 on the x-axis, go up to the graph, read it off. The output is 6. For 2, go up to the graph, the output is 4. And for 3, the input is 3, go up to the graph, read off the y-coordinate, 2. So once you see what's going on, graphs are not so bad either. All right, so we see that a function is a rule that assigns to each input an output, right? We take the input, we do something to it, we get an output. In order to be a function, though, every input has exactly one output. You can't have 2 outputs, or it's not a function. All right. Okay, in this example, we're going to draw what's called a cloud diagram. All right, we're going to copy the inputs into this cloud. 3, 4, 7. I'm not going to list the repeats. And the outputs in this one, 0, 6, and 9. And what we're going to do is simply draw an arrow from each input to the corresponding output. So when the input is 3, the output is 0. So it shows me where each input gets sent. Sometimes it's called a mapping diagram. All right, when the input's 4, an output is 6. And when the input's 4, we also have an output of 0. And when the input is 7, we have an output that is 9. Now, we want to answer the question, is this a function? Does every input only have one output? And the answer is no. This input 4 has 2 outputs. Input 4 has output 6, and it has output 0. So this is not a function. By the way, the set of inputs is often called the domain, and the set of outputs is called the range. And our diagram is just showing where every element of the domain, where its matching output is in the range. All right, well, real quick, let's try this one. It says create a table for this one. All right. Well, when the input's 6, the output is 9. When the input is 2, the output is 9. When the input is 7, the output is 8. And 13 gets sent to 8 also. So the question is this a function? Does every input get used only once? And actually, the answer is yes. No input gets used twice. It's okay for them to share an output. It's okay for an output to get used more than once. It's just no input can be used more than once. Okay, again, the set of inputs is called the domain, and the set of outputs is called the range. Every element of the domain is sent to exactly one element of the range. All right, well, you've been very patient. Thank you for going through all these examples. Here's your general assignment. And you can show your teacher you understand how to evaluate functions. That's very good. All right, see you next time.